and welcome to another WJEC A level physics question. This time it's question 4 from the January 2005 PH4 paper. It's a kinetic theory question which is nowadays in unit 3. We've got a cylinder of hydrogen gas of relative molecular mass 2.0 and a cylinder of oxygen gas relative molecular mass 32.0, and they're at the same temperature, and that's important. We'll come back to that later. How do the mean kinetic energies of the molecules compare? Well, it's a fact that we need to learn is that the kinetic energy of a molecule is directly proportional to the temperature. And because these are at the same temperature, it means that their kinetic energies are equal. Hence, we've got to calculate the ratio of the root mean square speed of the hydrogen molecules compared to the root mean square speed of the oxygen molecules. So what we can say here is half mass of the hydrogen molecules times the mean square speed of the hydrogen molecules must be equal to a half mass of the oxygen molecules times the mean square speed of the oxygen molecules. That's just simply stating that kinetic energies are equal. Remember, kinetic energy is half mv squared. So we want to rearrange this for ch squared bar over co squared bar, and we want to root it. So simple little bit of rearrangement. We're going to have half of mo over a half of mh, all square rooted. The halves will cancel. The mass of the oxygen is 32 U's, and the mass of a hydrogen molecule will be 2 U's. The U's will cancel. 32 divided by 2 is 16, and square root of 16 is 4. Let's just very quickly go over where I got these masses from. One of the facts that you should learn as you go through the course is that if you know the relative molecular mass of a substance, you know two things. You know the mass of a mole in grams, or times 10 to the minus 3 kilograms. So in other words, the mass of 1 mole of oxygen gas is 32 grams. But you also know that the mass of one molecule is 32 U's, where U, the unified atomic mass unit, is 1/12 of the mass of a carbon-12 atom. So learn those facts. The MR tells you the mass of a mole in grams and the mass of a molecule in U's. What's meant by a mole of gas? And it's the amount of gas that contains Avogadro's number of molecules. And that's 6.02 times 10 to the 23 molecules. Each cylinder contains 0.32 kilograms of gas, and we've got to calculate the number of moles. Well, here we can use one of those facts that I mentioned a few minutes ago. The mass of 1 mole of hydrogen is 2 grams, or 2 times 10 to the minus 3 kilograms. So if we take the actual mass and we divide it by the molar mass, 2 times 10 to the minus 3, an equation that is in the data book, we will get 160 moles. And for the oxygen, we can do a similar calculation. The mass of 1 mole of oxygen is 32 grams, and that will give us 10 moles. The cylinders are equal volumes, and the pressure of the oxygen is 100 kilopascals, and we've got to use the ideal gas equation or any other means to calculate the pressure of the hydrogen. So the ideal gas equation is PV equals nRT, and if we just rearrange that very slightly, we get P equals nRT over V. Now the point here is that R is a constant. Right at the start of the question it told you that the temperature is a constant, and the volume is a constant, as the volume is the same for both. So what this means is that the pressure is directly proportional to the number of moles. So the pressure of the hydrogen gas is going to be 16 times the pressure of the oxygen gas. That 16 comes from the fact that we've got 160 moles of hydrogen, 10 moles of oxygen. We've got 16 times as many moles of hydrogen. So the pressure of the hydrogen is going to be 1600 kilopascals. Next, or last part of the question, what mass of hydrogen would have to escape from the hydrogen cylinder before the pressure would become equal to the pressure of the oxygen? Well, again, using that fact that pressure is proportional to the number of moles, to have the same pressure as the oxygen, we need the same number of moles. So we've got 160 moles, we need 10 moles, so we must lose 150 moles. And the mass of 1 mole of hydrogen again was 2 grams. So the mass is going to be 150 times 2 times 10 to the minus 3, which is 0.3 kilograms. Thank you very much for listening. Please remember to like and subscribe, and feel free to leave any comments. Goodbye.